This is a very popular problem with calculus classes. Find the equation of a tangent line to f of x at the point where x equals 2. So just for some random f, here we have a random f. Here's some point x. We're trying to find the equation of this line. Now, it should be drilled into your head that the derivative of a function tells us the slope of a tangent line. So the equation of this line, which is y equal mx plus b, has a slope and a y-intercept, just like any line that exists on the planet. But the way that we find the slope is that we have to find f prime and evaluate it at the x value that we're given. And then we have to find the ordered pair where the point of tangency happens. And we plug that in to y equal mx plus b, and we get our equation of our line. Now, in intermediate algebra or any early algebra course, we learn very quickly when we need to find the equation of a line, we need a slope and we need a point that lies on the graph. The only point that we know that lies on this graph is the point of tangency, and we get the slope by using the derivative. It's always the same way. There's no other way to do these problems. So we have to get two things. So the first thing I'm going to think about is this point. Where do I get it? Well, in my problem, I know that x is equal to 2. How do I get the y value if x is 2? Well, I know that y equals f of x. So that means that to get my y value, I have to calculate f of 2. So that's going to be 2 minus 1 to the third. 2 minus 1 is 1. 1 to the third is 1. All right, so the ordered pair that I need is, put it over here, 2 comma 1. Now, I have to find f prime of x before I can find f prime of 2. So let's calculate f prime of x. I'm going to use the chain rule. I have this outside function, which is something to the third. So I take its derivative using the power rule. So I bring down the 3. I subtract 1 from the power. And then I take the derivative of the inside part and I multiply by it. But the derivative of x minus 1 is 1. So there's my derivative. Now to find the slope of my tangent line, that's going to be f prime evaluated at 2. That's 3 times 2 minus 1 squared times 1, of course, which is just 3 times 2 minus 1. That's going to give me 3 times 1 squared, which is 3. So I have a point and I have a slope from this information here. Now I go back to my intermediate algebra roots and I find the equation of a line that has this characteristics. So y equals 3x plus b. Plug in the point 1, 2, solve for b. That's a 2. So 1 equals 6 plus b. b equals 1 minus 6, which is negative 5. So my final equation for my tangent line is y equals 3x minus 5. And again, the pattern that we use here is the same all the time. We use the original function to find the point that the line goes through, and we use the derivative to find the slope of the tangent line every single time.